In this video, I will discuss about the methods of calculating area. The basic method for calculating area is that if I have two triangles whose base is on the same line and if they have a common vertex, then the ratio of their areas is the ratio of their base. For example, we have this configuration. The ratio of area of triangle APQ to the area of triangle ABC will be PQ is to BC. And we can extend this further. If I have a parallelogram with this, so the area of the triangle will be half of the area of the parallelogram. Now we have one more theorem, that is the vertex sliding theorem. It states that I can slide the vertex along a line provided I adjust the area accordingly. If that line intersects the base at a point x, say, then the ratio of their areas a dash x, a dash bc, or area of triangle a dash bc to the area of triangle abc is a dash x by ax. Now this was the basic statement of this theorem of calculating the areas, but the exact methodology differs from question to question. Hence we can have a good understanding of the concept by solving many more questions. Here is the first question. We are given that ABCD is a parallelogram. BC is extended to a point E such that BC equal to CE. AE is joint. We have to find the area of ABCD given that the area of DFA is 3. To solve any kind of question, we have to first understand that what defines the given configuration of that question. Here we are given that the area of DFA is 3, but we have to ask the question, what defines the point F? The answer will be AE. AE intersects with DC to create the point F. Now E is already defined using the lengths BC equal to CE. So now we have to, using this methodology, calculate the ratio of DF to FC. Now using in my video on the calculating length ratio, I have told how we can calculate this. DF by FC, it is defined by this line AE. So we can simply use the area property that we can join this, so we can get area of ADE by FC is area of ACE. Now area of ADE, this base, and this is the parallelogram, so half of the area of this parallelogram ABCD, and ACE, the base has the same length and the height is the same, so it will also be the half of the area of the parallelogram. See, this is the same base and this is h, and this is half into h into this base, so this one will also be half, so half will cancel, so this ratio will come to be 1. So DF equal to FC. Now once we have got DF equal to FC, we can very easily calculate. Since DF equal to FC, if I join this, then the area of this one will be 2 times the area of this one, because this both will have the same area. That is area of ADF equal to area of AFC. Since this both has the same area, so area of ACD will be 2 times this, so area of ACD will be 6, and area of ACD is also equal to area of ABC, because the parallelogram, diagonal of the parallelogram divides it into 2 triangles of same area, so this will also be 6, so our answer will be 12. Now let me solve another question. It states that AG is to GB is 2:1, then CE is to DE is 2:1, and BF is to FC is 2:1. We have to find the areas of the triangles ADEB, then ADEB, then EGB, EFC, and in terms of the parallelogram ABCD. So let us write down the information in this format. So if I have to calculate the area of ADEB, I can calculate it in parts. First, if I divide the figure like this, then I can very easily write that the area of ADEB is equal to the area of ABD plus area of BDE. Now the area of ABD, it is a diagonal, so it is half of the area of ABCD, and BDE, it is 1/3 of this one, and this one is half of the area of parallelogram ABCD. So we get half plus 1/6 of the area of ABCD, so we get 6, 3 plus 1, we get 4/6 of ABCD, which is also can be written as 2/3. So this one is done. Now EGB is this one. This one can be calculated using the same logic in which we have calculated, I think, this one. BDE, EGB is 1/3 of this area, 1/3 of this area, and this is only half, so 1/3 of half is 1/6 of ABCD. Now EFC, say 1/3 of this one. Notice that it is 1/3 of this one, and this one is 2/3. This one is 1/3 of this one, and this one is 2/3 of this one, and this one is half of the area of ABCD. So we get 1 by 9th of area of ABCD. Let me again explain this part of how we have calculated EFC. First we have done with this point, we have made this the vertex, this as the common line in which the bases are present. So if we take this as the vertex, it is 1 by third of this whole. And then considering this one is taking this as the vertex, this is 2 by third of this one. And since this is the diagonal, this will be half of the area of the parallelogram. So 1/3 into 2/3 into half. 2 gets cancelled, 1 by 9th of area of ABCD. Now let me solve another question. Yes. So this is our given configuration. We are told that ABCD is the square and these points F, G, H, K are the midpoints. So we have to find the area of KDC in terms of ABCD. Now before solving any question, we have to first check whether there are any more lines which we can join to create a meaningful figure. If I try to join C to E, see I get a triangle and I know that the area of triangle is half of the area of the parallelogram. ABCD can be assumed to be a parallelogram. So this triangle's area will be half of the area of this square ABCD. Then since this is the midpoint, then this one's area will be half of the area of this one. Then since this is the midpoint, this one's area will be half of the area of this one. Since this is the midpoint, this area will be half of the area of this point. Since this is the midpoint, this area will be half of the area of this one. So we get a series of halves, and if we do the product of all of them, we shall get our final answer. So we can state it like this, that area of KDC is half of area of this one. So this one is half of the area of this one is half of the area of this one, then this one is half of the area of this one, and then this whole one is half of the area of the square ABCD. So we get 4 4 4 is 16, 16 2 is 32, 1 by 32 into ABCD. Let me explain again. So this one's area will be half of this one, we have written here half. This one's area will be half of this whole. Since these all are midpoints, that is why I am calculating using halves. Then this one's area will be half of this one, then this one's area will be half of this one, and then since this is a square, it is a triangle and the area of the triangle is half of the area of parallelogram, so we have put another half here, so it will be 1 by 32 into area of ABCD, and this is our answer. Now let me tell you about a different type of question in which we are given the areas of these three triangular regions and we have to find the area of this polygonal region. To solve questions like this, we need a different methodology. We need to solve using our concepts of length ratio. If I join this F and A and let me denote the area of this figure by X and this figure by Y, then I have to solve multiple equations to calculate the value of this X and Y. First of all, if I try to equate all the areas that can be formed using this line, so AE by EB, using my concept of length ratio, I can tell that I want to relate the length ratio to the area ratio. See, I can relate it by this one, X by 3, and the same area can also be related to this whole region, that is X plus Y plus 7 divided by 10. Now using the method of component 2 and dividend by, if I subtract these two, then I shall get X plus 7 by 10 minus 3 7. So one equation that I can frame is X by 3 equal to Y plus 7 by 7, and this is one equation. And another equation I can form using this point, that is AD by DC, and I can calculate this as Y by 7. Same thing I can extend to here, X plus Y plus 3, X plus Y plus 3 divided by 14, and taking the component 2 as I did earlier, so it will be X plus 3 by 7. So I can get another equation, Y by 7 equal to X plus 3 by 7. It is the second equation. If I solve these two equations, I will get my value of X and Y. I can show that how I can do that. See, I can get Y equal to X plus 3. Now I substitute this in that equation, X by 3 equal to Y equal to X plus 3, X plus 10 by 7. So cross multiplying, 7X equal to 3X plus 30. So we get 4X equal to 30, or X equal to 15 by 2, right? So, and using this we can also calculate the value of Y. So Y will be what? 15 by 2 plus 3. And what is X plus Y? X plus Y is nothing but 15 by 2 plus 15 plus 3 is 18, and 18 is our answer. Now let me tell a different kind of question in which we are given this three squares of side lengths, one is 2, one is 3, and one is 5. These are the side lengths of the squares. They are arranged side by side, and one line is drawn from this end to this end. It encloses a region ABCD. We have to find the area of this region. First of all, we can identify that since this is a square, these two sides will be parallel, and since these two sides are parallel, we get a trapezium in this case. And notice that this one is perpendicular since this is a square. So using the area formula of the trapezium, half into sum of two parallel sides into distance between them. Distance is perpendicular distance. It is given to be as 3 because it is a side length of the square. Hence all we have to do is we have to calculate the lengths of these two, and then we can get our answer. To solve questions like this, we have to use the concept of similarity and basic proportionality theory. It is 2, let us assume it to be x, let us assume it to be y, and it is 5, it is 5. Using the concept of similarity, we can tell that 2 by x is equal to 2 plus 3, 5, 5 plus 5, 10 by 5 equal to 2. So we can directly get x equal to 1, and 2 plus 3 by y equal to 2 plus 3 plus 5, 5 plus 5, 10 by 5 equal to 2. Then y equal to 5 by 2. Then using our concepts of area, we can tell half into, it is a part of mensuration, that is why I have not separately told the area formula of trapezium. We can derive it very easily. Half into sum of two parallel sides into distance between them, distance is 3. So what is it coming out? Half into 5 plus 2, 7 by 2 into 3, it comes out to be 21 by 4, and that is our answer. Now let me tell another very important question. Yes. So here we are given a square ABCD. M, N, O, L are the midpoints. These are joined accordingly. We have to find the area of PQRS in terms of ABCD. Now these kind of questions and questions like this may seem to be too complicated. To solve these questions, we cannot directly calculate the areas. We have to subtract the areas from the main figure so as to get the required area. See, I cannot, or it will be very difficult to calculate the area of PQRS directly. Instead of that, I can very easily calculate the areas of these triangular regions. And if I calculate the areas of these triangular regions and I subtract it from the total area, I will get the area of PQRS, and that will be exactly my strategy. Calculating the areas of this triangular region is not too simple. To calculate that, we need to take the help of length ratio. See, I have tried to calculate the location of this point PQ to QM, but it is too hectic, means too difficult. That is why I have not done it. So instead that, if I try to locate the position of BP to PM, see, this is quite easy than locating the position of Q. It is by hit and trial method. We have to see which method is more efficient than the other, and we have to choose that method. So this method is efficient because if we try to calculate this point's location BP to PM, then it is defined by this line AN. So we can calculate this ABN by AMN. Now ABN's area is half of the area of the square ABCD, since this is the triangle and this is a parallelogram, so this will be half of the area of ABCD. And AMN, see, this triangle AMN will be half of the area of this whole, and this whole area will be half of the area of this one. So half into half of ABCD. Let me tell it again. AMN will be half of the area of this one, that is why I have written here half. This area will be half of the area of this one, this square along the diagonal, and since the diagonal divides into two squares of equal area, so this one will be half of the area of ABCD. So I get 4 by 1. So that is the main key here. So we can write BP by BM is 4 by 5, because here we got 4 by 1, this one is 1. So BP by BM, the whole will be fifth part, so 4 by 5. Now we can calculate the area of this one very easily. So using the area theorem, BPA by BM, we can do this by BAM is 4 by 5. So BPA is 4 by 5th of BMA. BMA is nothing but half into this one, this whole, and this is the square and this is a parallelogram, so half into half of ABCD. Let me tell it again. BAM is half of the area of BAD, and BAD is half of the area of ABCD. So it comes out to be 1/5. BPA comes out to be 1/5 of the area of ABCD. Now using the property of symmetry, we can say that if this is 1/5, this one should also be 1/5, this one should also be 1/5, and this one should also be 1/5. So we get 4 triangles, 1, 2, 3, 4, and so we can directly say that the area of PQRS can be written as area of ABCD minus, we get 4 of these triangles, so 4/5 of the area of ABCD. So the answer will be 1/5 of area of ABCD, and this is our answer. Now let's look at one more very interesting question. We have 3 squares placed side by side. Obviously all of them will have the same side length, this point is joined with this point is joined with this, and we get a triangular region like this. We have to calculate the area of this triangular region in terms of any one of the squares. All of the squares will obviously have the same area. To proceed, I will retell what I have told before in this video. We have to understand the defining characteristic of the given configuration. What defines this configuration? See, A is joined to point I. So somehow this length ratio I have to find. That is, it is connecting this. So this point can be said to be a defining characteristic of this whole triangle, because again this one will be divided at this point. When I will join this to this, I will get another point. But before getting this point, I must get this point. So this is the first defining characteristic which I have to find. Then I have to find this point, because this line must intersect with this to create this point. And after this intersects with this, BH intersects with AJ, then only I can get C. So first I have to locate the position of F, then I have to locate the position of H. Then after defining this, I can define the point C, and after defining C, I can calculate the area. So first of all, I have to locate the position of J. I will do this using the concept of length ratio. I have already discussed it in the previous video. So BJ by JD. BJ by JD can be written as, see, it is defined by this line, right? So BJ by JD can be defined as ABI by ADI. Now ABI, see, this is the base and this is on the same parallel, so half of the area of ABDE, this square's half. Then AD, the same base length, since these have the same side length, this is the same base length and same parallels, so this will also be the half of the area of this square. So both of them will be the half of the area of the same square, hence they will cancel each other and the ratio turns out to be 1. So BJ equal to JI. Now we will do the same for this one. Even if we do, we can directly tell that this one will also be the half, because there is some symmetry in this figure. If this point intersects this square after two squares, means after one square it is intersecting, and this is also intersecting after one square, so more or less the same configuration is there, so we can also tell that this will also be the half. But still, let us calculate to confirm that it is truly half. EH by HD, it is defined by this line, so EH by HD will be EBF by HD will be FDB, EBF FDB. So EBF, see, this is the base, same parallels, half of the area of the square, and FBD, this is the base, same parallels, half of the area of the square, both will be half of the area of the same square, hence they will be 1. So EH equal to HD. Now we have to locate this point's position. Once we are successful in locating this point's position, we can very easily calculate the area. So AC by CJ, how can we locate? We have to first check out the defining characteristics, this line and this line. So it will be this area, AC AHB by BHJ. Now AHB will be half of the area of the square, and BHJ, see, this will be half of this one, this will be 1/4 of this one, and this will be 1/8. So this one will be 4. So it is 4/5 of this length. Now AC by AJ is 4/5. So corresponding areas ABC by AJ, we can get ABJ is 4/5. So we can directly say area of ABC is 4/5 of area of ABJ. Now the area of ABJ is nothing but 4/5 into area of ABJ is half of this one, and this one is half of this one. So 1/4 into area of ABDE. So the answer is 1/5 of area of ABDE, and this is our answer. Now let me tell some more questions. In this question also, we cannot directly calculate the area of PQR. We have to do it by subtracting it from the whole triangle ABC. First of all, we can see directly that what we have to subtract. We have to subtract the areas of these triangles from the entire triangle to get PQR. So we have to first calculate the area of triangle BQP. BQP will be nothing but, if I take consider this at the vertex, so 4/6 of this whole triangle, and this whole triangle considering this at the vertex, 4/6 of this whole triangle, this one will be 3/8, 5 plus 3, 8 of this whole triangle of ABC. So you can see 4 2s are 8, 3 2s are 6, 1/4 of ABC. So this one is done. Now we will calculate the area of CPR. CPR, let's take this as the vertex. So 5/8 of this triangle, and this triangle is 6 by 10th of triangle ABC. So it comes out to be 3 by 8 of triangle ABC. Now let us calculate the area of this one. AQR. See, if I take this, so 4 by 10th of this whole, and this whole can be written as 2 by 6th. 2 by 4 plus 2 6th of triangle ABC. So this can be written as 5, and this is 2, this is 3. So we can get as 2 by 15th of triangle ABC. 3, 2, 5. Yes, it is correct. So now if we want to try and calculate the area of PQR, it is nothing but area of ABC minus this whole, 1/4 plus 3 by 8 plus 2 by 15th of ABC. Now it is pure calculations. Let us take, what shall we take? We can take it, what will be the LCM? Let me calculate the LCM. So this comes out to be 2, 4, 15. So 30 into 4, 30. 15, 3 are 45. 30 into 4 by 15, 15 into 4 to the 8. 8 on the 16. Okay. So we get 30, 16, 6, 46. 1 minus 91 by 120 into area of ABC, which comes out to be 912. 29 by 120 into area of ABC. So this is our answer. Now let us solve this question. The numbers denote the areas, and this is a rectangular region. All the above are sub-rectangular regions. We have to find the area of this region. We can see that these two have the same length, same breadth. So the length ratio will be same as their area ratio. Here, so the length ratio will be 10:4. That is, if I take it, simplify it, it will be 5:2. Yes. Now since these have the same breadth, so the length ratio will be ratio of the breadths. So this one will be 4:5. 5, 5, 15, 4, 3, 12. Now this one, this length is common, so this breadth ratio will be their length ratio, will be their area ratio. So 3:5. 5, 3, 15, 5, 5, 25. Now we will consider the most simplest case. Like we do not need to assume any variables. We can just take for the sake, since it is an integer answer type question, we can just assume something and get the correct answer. Let us assume this length is 4. If this length is 4, then we have to multiply this 2 by 2, so we get this one as 4. And if this one is 4, we have to multiply this 5 by 2, so this one will be 10. If this one is 4, this one will be 5, since the ratio is 4:5. If this one is 5, and we have not done anything to this, see, this one will automatically come to be 1. And this one is 3, this one is 5. Right, so the area will be this one we have got up to be 10, and this one we have got to be 5. So the area will be 50, and 50 is our answer. It is completely based on observation. No need of any complex mathematical skills. We can just observe and simply take some values and solve this question. Now coming to some of the most difficult questions. This one, we are given AE is to EB is 1:3, and all the above ratios are 1:3. We have to calculate the area of KLM. So as discussed in the previous example, to calculate the areas of the remaining portions, we have to first find the length ratio. So here we have to find the ratio of CK to KE. We can do this by defining the point K. It is defined by this line AF. So it will be the ratio of ACF to ABF. We can write ACF as 3/4 of this whole triangular region's area, and ABF. What is ABF here? ABF is 1/4 of this whole triangular region's area. So this one will be 3/1. So this is 3:1. So CK is 3/4 of CE. Since it is 3/4 of CE, we can define this as area of triangle CKA by area of triangle CEA. CEA the base ratio, so 3/4. So area of triangle CKA will be 3/4 of the area of triangle CEA. And what is the area of triangle CEA? 1/4 of area of triangle ABC. So it is nothing but 3/4 for the 16. 3/16 of area of triangle ABC. So this triangle's area we have got. Similarly, we can calculate this one and this one. We can conclude that due to symmetry, all of them will be the same. So we can simply multiply it by 3 and get that the area of KLM will be area of ABC minus this will be multiplied by 3 is a minus 9 by 16th of area of ABC. It will be nothing but 1 minus 9 by 16th of area of ABC, which will be 16 minus 9, which is 7 by 16th of area of ABC, and this is our required answer, 7 by 16th. Now let us come to this question. Here we are given that E, F, G, H are the trisection points, and we have to calculate the area of PQRS. So we can sense some sort of symmetry in this figure PQRS. To solve this question, we will first join P and R. First try to calculate the area of PQR, because calculating the areas of triangles is much more easy than calculating the areas of quadrilateral. So if we want to calculate the area of PQR, first we have to find the length ratio of the location of point Q and R. To find the location of point Q and R, we have to calculate the length ratios. So BQ by QH, since this is defined by this line, so it will be ABE, area of A, QHC, AHE, AHE. Now ABE will be 1/3 of this whole triangle, and this triangle will be half of the area of the rectangle, so it will be 1/3 into half into area of ABCD. And AHE will be 2/3 of this triangles, and this triangle will be half of ABCD. So we finally get half. So BQ equal to 1/3 of BH we can get, and we have to find BR by RH. See, this can be defined by this line, it cuts, so it will be this area by this area, BAF, and BR by RH, so BAF by AHF. Now BAF is 2/3 of this triangles, and this triangle is half of this whole quadrilateral ABCD or rectangle ABCD, and this AHF is also 2/3 of halves of this one, so this will be 1:1. So we can tell that BR is 1/2, means half of BH. So using this we can calculate the length of QR. QR will be 1/3, half minus 1/3 of BH, which will be 1/6 of BH. Since we have got this ratio, since we can relate this triangle now, but before that we must also have to define the position of point P, right? Because without P we cannot do that. So defining the position of point P also, we can say that BP by PG is nothing but this point is defined by this line, so area of ABE by area of AGE. See, these two areas are equal. Again, using the same logic, 1/3 of half, 1/3 of this one is half of this one, and this one is also the same formula, so this one will be equal. So BP equal to half of BG. Once we have defined this, now we can proceed towards calculating the area of triangle PQR by area of triangle BPH. Since I have taken the base C, BPH, and I have taken, so this one will be QR by BH. QR by BH 1/6. So area of triangle PQR is 1/6 of area of triangle BPH. Now we have to calculate the area of triangle BPH. Using the same logic we can calculate is BPH by area of triangle BGH. BGH is BP by BG. Now BP by BG is half, so area of triangle BPH is half of area of triangle BGH. Now the area of triangle BGH is 1/3 into half, so 1/3 into this one, and this one is half of ABCD. So we get 6 to 12, 1/12 of ABCD. Now substituting this into this formula, so PQR will be 1/6 into BPH is 1/12 of ABCD. And since there is a symmetry in this figure, the same way we can calculate the area of this region also. So simply multiplying this by 2, PQRS area will be the product, means by multiplying this by 2 we can calculate it, since there is a symmetry. So we get 1/36 of area of ABCD. Now let me discuss a very different type of question. It is given that ABCD is a quadrilateral, and these points are the trisection points of its corresponding sides. Then we have to find the area of this region. To find the area of this region, we have to first find the area of this region. So let me redraw the figure. We have ABCD, and we want to calculate the area of this region where these points of the trisection points. To calculate the area of this region, we have to first divide this region into triangles. Let me join these points so as to form triangles. See, I can form this triangle, total 6 triangles I can form in this figure. I will try to relate the areas of these triangles. To relate that, imagine the triangles are like this, that is, here is point A, here is point P1, here is point P2, and here is point B, here is point D, here is point Q1, here is point Q2. I have just extended this line, to meet AB at point X, since it is not given whether they are parallel or not. I have just imagined, and this is point C. So the triangles that I can get, one set of triangles will be like this. This is my one set of triangles. I will try to relate the areas of these triangles. Let me assume that this distance is X. Let me assume this is A, and since these lengths are equal, it is the trisection point, so this will also be A. Now I will try to transform this triangle to a new triangle whose base is this one, and it has a common vertex. So the new area will be area of P1 P2D by area of P1 AD will be the ratio of their bases, and since their bases are equal, so the area ratio will also be equal. Area ratio will be 1, or the areas will be equal. Similarly, I can also say that if I want to transform this triangle to this base with the same vertex, P1 P2 Q2 by P2 B Q2, the bases are equal, so this ratio is also 1. Now I have 3 triangles. I will try to relate their areas using the vertex lighting theory. Area of triangle P1 P2D by area of triangle P1 P2 Q1 can be written as X by X plus A. Similarly, area of triangle P1 P2 Q2 by P1 P2 Q1 can be written as X plus 2A by X plus A. Now I want to relate this area, so let me do one thing. Let me add this one, P1 P2D plus P1 P2 Q2. If I add these two ratios, then what I get is that X plus X, 2X plus 2A, 2 into X plus A, and X plus A is also at the denominator, so this comes out to be 2. So I get a very important result. P1 P2 Q1, this value is half of the area of P1 P2D plus P1 P2 Q2. So in our given diagram, let me denote this area by A and this area by B. So this area is half into A plus B. Similarly, using the same logic, if we denote this area by C, this area by D, so this area is half into C plus D. And this entire region's area, that is A plus B plus half into A plus B plus C plus D plus half into C plus D, is our given area. Let me assume it to be delta. So what we get is that 3 by 2, 1 plus 1 by 2, 3 by 2 into A plus B plus C plus D is delta. So what we get is that half into A plus B plus C plus D is delta by 3. So this region is half into A plus B plus C plus D. So this is equal to the total region area divided by 3. So if you want to extend this to this figure, the same trisections have been made here. So this figure has also been trisected. So this one will be 1/3 of this entire one. So this one will be 1/9 of this entire figure, and this is our answer.